Let's continue solving exponential equations, but we are going to change things up in this lesson just a little bit. But before doing so, I want you to take your note-taking guide and I want you to turn to the second side of that note-taking guide handout. And I am going to choose these 4 problems I'm going to mark right now as warm-up problems because they look like problems that you saw in section 10.2. So would you please work on 9, 10, 11, and 12, solve for x, and you are going to use the strategy of finding common bases. Okay, so pause the video and complete these 4, and when you are done, return. Okay, so at this point, you should have completed these 4 problems, and you would have used strategies that you used in section 10.2 to solve exponential equations. So let's look at the first equation. So we have one side of the equation, 5 to the negative x equals 5 to the 2x minus 6. We recognize that the bases are identical in both sides of the equation, so we can use the one-to-one property to drop those values, and we're able to set the exponents equal to one another. So literally, we can just ignore those 5s, right? And then we're just going to merely proceed to solve this equation. Negative x plus negative 2x gives me a negative 3x. Negative 2x and negative 2x become 0, and we bring down the negative 6. Therefore, we will divide by negative 3 on both sides to get x equals to 2. Okay, so that would have been your first answer. We'll come back over here to the next one. Now over here on number 10, our bases are not identical. So the 3 that we have here is not matching the 243 over here, just like it did over here with the 5, okay? So I need to force 243 to have a base of 3, because 3 and 243 can be rewritten with a base of 3. So since this side has a 3 already, I'm just going to keep 3 to the 1 minus 2x intact, but I'm going to force 243 to be rewritten in exponential form as 3 to the 5th power. And in doing so, I am able to again apply the one-to-one property. I'll write that down here so you recall one-to-one property, which many of you like to say I'm going to cancel, but get accustomed to saying one-to-one property. And we will bring down the exponents and now just solve the equation. So I'm going to keep my x's on the left-hand side. So I'm going to move the 1, which is requiring me to subtract 1 on both sides, bring down the negative 2x. 5 minus 1 is 4. And once I divide both sides by negative 2, I'm going to get x equals negative 2 for this one. Okay. All right, so hopefully so far things are going well with this section in 10.2 so that you are able to handle what's coming your way in this next section. All right, so next here, actually let's jump to let's just do number 11, that's fine. So 4 to the 3x minus 2 equals 1. So here again, we do not have a situation where our bases are the same. And so we have to decide, what do I want my base to be? Now 4 can be rewritten with a base of 2 or 4. 4 is 2 squared or 4 to the 1st power. So can 1 be rewritten with a base of 2 or 4? And actually it can. So what you guys need to remember with this problem of number 11 is remember that any number raised to a power whereby the power is 0 will always, always end up being equal to 1. Okay? So 2 to the 0 is 1. 2, already did 2. 3 to the 0 is a 1. 4 to the 0 is a 1, and so forth. Okay? So, because I know any number raised to a 0 will be 1, I can use either the 2 or the 4 as a base for this problem. So I will either write 4 as 2 squared, open parentheses 3x minus 2, or I can use 4 to the power of 1, which I won't write the 1, and just leave it as we see it right now. So I'm going to choose the 4 actually, since our problem is already a 4, because 1 can be rewritten as 4 to the 0 power. So now apply the 1-to-1 property, and I'm left with 3x minus 2 equals to 0. I need to add 2 to both sides, so 3x will equals to 2. And then when I divide both sides by 3 to isolate my x is going to equal 2/3. Okay. All right, last one that you guys reviewed. So here we go. We had 7 to the 2x plus 1 and 1 over 49. Now, 1 over 49 I recognize is the same as saying 1 over 7 to the second power. And so I know by the rules that I can rewrite 1 over 7 squared as 7 to the negative 2 power. So now, when I set these values equal to each other, the 1-to-1 property will be applied, and I will be left with 2x plus 1 equals negative 2. I will then not subtract 2, sorry. I'm going to subtract 1 on both sides to get 2x equals to negative 3. Then I'm going to again divide by negative 2. Not negative 2, my bad. Positive 2 on both sides so that I can isolate the x, and x equals negative 3/2 just will stay as negative 3/2, and you are done. So in these 4 examples, again, that mimic those problems that you did in 10.2, all these problems we are finding common bases. So we are finding common bases up here to be able to solve the exponential equation. But look what happens in the next few problems that we're going to work out. So on the front page, when you move over to the front page, we didn't work out every single one of the problems in this note-taking guide, but we did just enough to go ahead and let you guys start and getting the work done, okay? So let us start with problem number 1, all right? So let's go here. Let's choose a different color to capture our attention. So right now, this particular problem, number 1, it's 4 to the x minus 6 equals 4. And I want you guys to always try to get, let me erase this here, it's not writing correctly, to always try to get your equations written in this format. B to the power of a equals a. I'm always trying to get you guys to write an exponential format where you have a base equals, raised to the power of your exponent equals n, okay? And if you want to make it easier for yourself, if you just want to use x as an exponent, you can do that as well. And then what happens is, I want you to replace, I'm going to go back to a because that's what you guys used in 10.2. You are going to rewrite b to the n equals n as a log. And when you rewrite it, it's log Let me see if I can write that here. It's not liking me. Hold on. Oh, did I just freeze? There we go. Sorry. So we're going to do log of the base of the number will always equal your exponent. Okay? So you can rewrite back and forth, but if it's an exponential, rewrite it as a log when necessary. So 4 to the x minus 6 equals 4. I'm going to solve for 4 to the x. So I need to add 6 on both sides. So I'm going to add 6 and add 6. And I'm going to end up with 4 to the x power equals to 10. Okay. Now what I want you to notice is that here's a situation where trying to get the 4x and the 10 to have a common base is going to be highly impossible. Okay. 4 has bases of 2 and 4, but 10 cannot. 2 to the power of nothing will give me 10. 3 to the power of nothing is going to give me 10, and so forth. It's impossible to get a common base, okay? So, common base strategy. Common base strategy is not going to work, okay? It's a huge fail. So what you're going to do is I need you to rewrite it in log format. So log base 4 of 10 equals x. Okay, so what you're going to do is you're going to type this into the calculator. So if you go over here to your calculator, there's a math button underneath the alpha. I want you to press the math button, and then I want you to arrow up. Press the arrow up button a few times until you get to log base, which is option A. You're going to hit enter on option A, and you are going to type log base 4. I think it was log base 4, right? Let me go back and check. Yeah, log base 4 of 10. And I'm going to hit enter, and you get 1.66096. Well, since we're rounding to 4 decimal places, the 6609 is going to be 6610. So let's go back to that. Where is my... So x is going to equal the rounded answer of 1.6610. Okay? So there's that answer. Alrighty, we keep going. Let's do number, let's try number 6, I think it was. Nope, number 5. Let's try number 5. So number 5, let's solve for x again. So the first thing we're going to do is add 4 to both sides, okay? Let's go add 4. So add 4 and add 4 on both sides, because we're trying to get this equation to look like an exponential equation. So 3 to the 2x plus 6 is going to equal 17 plus 4 is 21. Now I need to divide both sides by 3, because I need to get my base to my exponent all by itself, okay? I always want to get the base and the exponent all by itself. So now I'm left with 2 to the x plus 6 equals to 21, okay? So again, doesn't that look like the format of the base to the power of a equals n, right? What I need you to imagine is that this is your b, this is your a, right? And this is your n. Those are your 3 components, and you have to write it in that format every single time, okay? So, since we cannot get common bases here between a 2 and a 21, okay, that's impossible, we are going to write it as a log. So, log of the base is 2, of the number 21 equals x plus 6. Okay, but I'm solving for x, so I must get rid of the plus 6 to the other side. So opposite of positive 6 is negative 6. And now my answer is going to be log base 2 of 21 minus the 6. That's going to equal my x. So let's go to our graphing calculator to type this out. Log base 2 of 21 minus 6 equals x. Let's go over here. I'm going to press math again. I'm going to arrow up. Went a little too far. I'm going to hit enter, and I'm going to type in, what was it again? Log base 2 of 7. And then I need to subtract 6 from the log base 2 of 7. And I get negative 3.19264. So rounding to the hundredths place, not hundredths, 10,000ths place actually, the 4 decimals, is negative 3.1926. Okay. So wrapping up this answer right here. Let's move on to the next one. Let's go to number 2. All right, with number 2, what we're going to do again is make this equation look like this. A number raised to another number equals another number, right? So right now, the 12 goes very well inside of here. My exponent goes very well right here. But then what the 3 and the e, they don't go together. It's 3 times e to the 2x. So the e has to go here. So the 3 is kind of just stuck there, right? So I need to get rid of the 3 by dividing both sides and get e to the 2x equals to 4. So now, do you see how it looks like that format? So much so that I can take this 12 now and put a 4. Okay, so your exponential must always be written in this format to be able to rewrite it as a log. So log of base e of 4 is equal to 2x. Okay, now I need to solve for x. Before I do so, I want you guys to recall that we had a discussion before that anytime you see log base e, you will rewrite that as ln, which is natural log of 4 equals to 2x. Okay. The natural log button is on the calculator right below the log button, okay? So I'll show you in a bit. Now I need to divide both sides by 2 to isolate my natural log 4 divided by 2 to equal x. So again, just reminding you that this is an L, not a 1, and that's called the natural log. Okay. So let us go to the calculator and type ln 4 divided by 2. So ln is right here by the 4. Oh, let me do alpha y equals to make that stack fraction first. So ln 4, and I'm going to divide by 2 to get 0.6931 as my answer for x. So x equals 0.69, I already forgot the number, 6931. and you are done. Okay. So all I had students do were these 5 problems for practice, and then all remaining problems on this lesson is opportunities for you to practice these type of problems. So I'm going to have you finish off number 6, and when you do it, you should get the answer x equals negative, whoops, it's a big negative, 0.2310. So my hope is that you will work out number 6 just before closing out your notes and try to end up with x equals I forgot my negative. I even said it, but I forgot to write it. Negative 0.2310. Okay? I'm going to scoot this one in a little bit more because I'm just being me. All right. So hopefully this is not as hard as you at first felt it to be. Notice that it's highly calculated, calculator used. So ask any questions if you have any. I'm here, and thank you so much for watching. I'm sorry I'm being so picky with this 0.2310. All right, 22-minute video. Hope that was enough.